how to integrate 1 divided by x squared times the square root of x squared minus 4 dx. First of all, the thing that makes this integration difficult is the square root on top of x squared minus 4. Therefore, we can't use neither u substitution or integration by parts or integration by partial fractions. Therefore, we need to look for another method. This method is trigonometric substitution. Since we have inside the square root something like x squared minus a squared, something in the form of this. So, since we have this, we gotta substitute x for a times secant u. This is done because in this way we can get rid of the square root in the integration. You'll see in a couple of seconds. So, we gotta substitute x equals x equals 2 times secant u, because a, in our case, it's 2. So when we differentiate this, we got that dx equals 2 secant u tan u du. Now that we have all parts to substitute the whole integration, we go and plug in everything. So it's 2 secant u tan u du divided by 4 secant squared u, and inside the square root we got 4 secant squared u minus 4. So we start simplifying this equation, and we get that tangent of u divided by 2 secant u times the square root of 4 times secant squared u minus 1, which we know because of the Pythagorean identities that this equals tangent squared u. Now we're left with this, which is a lot better than this, which is the integration of tangent of u times 2 secant u times 2 times tangent of u when we simplify this square root, which we get which the tangents cancel each other out, and we are left with cosine u over 4, which is a lot easier to integrate than what we had in first place, that was this. So when we integrate cosine of u over 4 in terms of du of u, we get that the sine of u over 4 plus c, which is a constant. But we're not finished, since we have this in terms of u, and we started with something in terms of x. So now what we have to do is substitute back. So we gotta turn this from u towards x. So since we got that x equals 2 secant u, we can manipulate this and get it to look like x equals 2 over cosine of u, since secant u is the inverse of cosine u. With cosine u equals 2 over x, we can make a triangle, a right triangle, where this is the angle u, and since we have that cosine of u equals 2 over x, we gotta put in the triangle that the cosine of u, which is adjacent over hypotenuse, that's why this leg equals 2 and the hypotenuse equals x. So now, since we have that the sine of u over 4 plus c is the answer to our integral, with this triangle we can find the sine of u, which equals the opposite leg of u over the hypotenuse, which gives us this, the square root of x squared minus 4 divided by x times 1 over 4 plus c. So the final answer will be this.